Example 3. In example 3, we have 4 inequalities to solve. One thing to note is that what's on the left of the inequality is the same in each one of these, A, B, C, and D. The only thing that changes is the inequality. So for A, we're solving for where these, what values of x make the function greater than 0. For B, what values of x make it less than 0. For C, it's greater than or equal to 0, and D is less than or equal to 0. So we're still going to start this out the same way. So what we're going to do is find the zeros of the top and the bottom. So the zeros of the top we have x squared equals 0. If we take the square root of both sides to solve this, we're going to get x is equal to plus or minus 0, but 0 is neither positive or negative, so we actually just get one solution there. Now we look for values that make the denominator equal to 0. That would be where the function is undefined. But notice what happens when I try to solve this for x. So one way I can do that is to subtract 4 from both sides. And that would give me x squared equals negative 4. Sorry. Now, if I take the square root of both sides for this inequality, I'm going to get x is equal to plus or minus, and the square root of negative 4 is going to be imaginary because there's a negative, and the square root of 4 is 2, so it's 2i. So when you're solving rational inequalities, you really don't worry about the boundary numbers that are imaginary. You only worry about the boundary numbers that are real. So, let's just say that there are no real, I don't know why my pen isn't writing, guys, I'm sorry, no real x values that make the denominator equal to 0. So the only number we're going to put on our number line here is 0. All right, so now we're going to put the numerator here, the denominator here. Looks like I forgot 2 rows this time. So this row will be, the sign of the function. And then we'll just put a star where it satisfies the inequality, especially since we're solving 4 different inequalities. Okay, so I'm going to pick a number in this interval, which would be to the left of 0. So I'm just going to pick x equals negative 1 for my test value. If I plug negative 1 in here and square it, remember that negative 1 squared is equal to positive 1. And if I plug it in here, I'm going to get negative 1 squared, which is 1 plus 4, which is 5, which is also positive. So the sign of the entire function would be positive. Now let's pick a number to the right of 0. Let's say 1. Well, I'm going to get the same thing because when you square negative 1 and when you square 1, you get 1. So this is going to be positive and this is going to be positive, which means the whole function will be positive. So now let's think about our solutions. If we want to know just where the function is positive, you might be tempted to say all real numbers. But remember that when x is 0, the whole function would be 0 over 4, which is actually 0. So that's not positive. So for A, we would have to leave out 0. So I would say from negative infinity up to 0, union 0 to infinity. B is asking us where this function is less than 0, or where is it negative? Well, it's not negative anywhere. It's positive here, and it's 0 when x is 0. So this would be no solution. What about C? C is asking where it's positive and where it's 0. Well, it's positive on these intervals, and it's 0 at 0, so this would actually be all real numbers. And finally, D is less than or equal to 0. We know it's never less than 0, and it's only equal to 0 when x is 0. So remember, when you have a single number that's a solution to your inequality, you put that in braces, and there's only one number that would satisfy D, and that is when x is 0. So this was kind of a special circumstance, but notice that we still use the same process to solve it, and we just need to think through what each inequality is asking of us.